In this video I'll cover the preliminary work for 14.5 energy cells and criterion P4. In P4 we need to explain the differences between primary and secondary cells. So an energy cell consists of three main components. You've got the anode, the cathode and electrolyte. And what happens when you connect a circuit between the anode and cathode? Chemical reactions take place here and here, and that enables electrons to flow through the circuit and operate the electrical circuit. So for that reason, because you've got this combination of chemistry and electricity, we call those electrochemical reactions. Now you can have two types of cell. You can have primary and secondary cells. Primary and secondary cells. And the difference between the two types of cell is whether they can be recharged or not. So the first thing to do in the preliminary task is to state the differences between a primary and secondary cell. Primary cell cannot be recharged. So you can only use that once. Once it's been discharged, you can't use it again. Secondary cell, you can recharge that, and the way that you do that is you take it off the circuit and you put it into another circuit where you put a power supply that forces the current to flow the opposite direction. So during discharge, electrons were flowing this way around the circuit, and what we do is we put a larger power supply here, if it was a secondary cell, like that. So the negative terminal of the battery is pointing this way, and that forces electrons to flow the other way. And what will happen then, when we force the current to move the other way, is the reverse reactions will happen here. So the reaction that happened here will be reversed, and the reaction that happened here will be reversed. So a primary cell cannot be recharged, you can only use it once. When it's fully discharged, that's it. Secondary cell, you can recharge, therefore you can discharge it, and then you can recharge it and discharge it again. And secondary cells can be used many, many times, and each type of cell has its own number of cycles. One cycle is a discharge and recharge cycle. So that's the point. In each case, both primary cells and secondary cells are storing energy for you to use in a particular case. So, like my iPad's got a cell in it storing energy that I can use. Right now, when I turn it on and start using it, I'm using it. That's discharging it. And so that's the cell is losing energy. I'm using the energy on the iPad, and then I'll recharge it so it will gain energy then, because my power supply will provide energy to it. And the reversal of the chemical reactions, you need to apply an electrical current to do that. So the difference is that with the primary cell you can't reverse the reactions by applying electrical current, whereas you can with the secondary cell, you can reverse the reactions with the electric current. Now let's look at a little more detail at the operation of primary cells. Primary cells, same three components. Primary cells can't be recharged, so they can only be discharged. So for that reason, there's only one set of chemical reactions to take place. One chemical reaction takes place at the anode and one at the cathode. I'm not going to write down the actual chemical reactions here. For both the primary cell and the secondary cell, when you have to write down the reactions, the discharge ones will always be given to you, and then for the secondary cell you have to work out what the reverse is. But for now, what I'm going to use instead of the actual chemicals are just letters A, B, C, D, and so on. Okay, so the reactions are always given. Discharge. And the example that you'll be looking at in the preliminary task is for a zinc carbon cell. So you've got a zinc anode, carbon cathode. Okay, at the anode, when a cell is discharging, there is an oxidation reaction that takes place. And at the cathode, the opposite type of reaction takes place, which is a reduction reaction. So oxidation at the anode, reduction at the cathode. And at the anode, we have two chemicals in the zinc carbon cell. Sorry, not zinc. A plus B are my reactants, and the products are C plus D plus E. So there's two reactants, three products for this oxidation reaction at the anode. At the cathode, it's a reduction reaction, and we have some new chemicals here, F plus G plus H. I'm starting at F because I've gone up to E there. And so I've got three reactants here, and these get turned into, they get turned into two products. So, as I said, you'll know what the actual chemicals are from your resources, but I've just used these letters to represent them. You can't reverse these reactions by applying electrical current because it's a primary cell, as we said earlier, and so you can't reverse the reactions. The reason for that is that we can't get this chemical back from this. Okay, so we can't get, so this combines, undergoes this reaction, turns into C, we can't get A back from C. So that's why you can't reverse the reaction. And that's our example for primary cells. Now I'll rub this off and we'll look at secondary cells. Okay, secondary cells then. This is the example for the secondary cell. And the example we're using is a nickel cadmium cell for the preliminary task. Here you have two sets of reactions, discharge and charge. Discharging and charging reactions, so you've got two lots. As I said earlier, the discharge reactions are given to you, so you'll have those in your resources, and then the charging ones you have to work out. So, discharge. Okay, these reactions are the ones that are given. So, let's have the anode here, and cathode here. Again, I won't be giving the actual chemicals. You need to look that up in your resources. Right. Just as with the primary cell, during discharge, at the anode we have oxidation. And this is, the anode is the cadmium, and this is nickel. Well, I think it's nickel oxyhydroxide, but yeah, all the cadmium reactions are going to take place there, and the nickel one's there. This is oxidation. And opposite of oxidation is reduction. We can't have the oxidation reaction taking place without the reduction one. Okay, So it's not possible, for example, to have oxidation and oxidation, or reduction and reduction, and that applies also for the charging reactions. Right, at the anode we have A plus B reacting to form C plus D, and then at the cathode we have E plus F plus G reacting to form H plus I. So those are discharging reactions. Yeah, we have a reduction here. Right, charging. These are not given. So these are the ones you have to work out. Here we have the reactions reversed. So let's draw our cell out again. This is the cadmium anode. Cathode here. This is nickel. Right, this time during charging, at the anode you have the reverse reaction taking place. So that's a reduction one. And here you have oxidation taking place at the cathode. So we've already said it's charging up there. So at the anode we have reduction, cathode. Not sure why I keep doing that. So let's reverse this reaction. The reactants become the products, and the products become the reactants. So we start with C plus D, because we've just formed a lot of that during the discharge process, and that gets turned into A plus B. And at the cathode we have H plus I reacting to form E plus F plus G. And that's our charging reactions. Notice that the chemicals at the anode involved in this first reaction are still involved here, but the reaction is reversed. So it's not the case that this is reversed and then goes down here to the cathode, and the same with the cathode reactants. The cathode reactants are E, F, G, H and I. The cathode reactants and chemicals H plus I plus E plus F plus G. So they're all the same chemicals at the same electrodes. And that's our example secondary cells. So now on to how you use primary cells and secondary cells. Let's rub this off again. Why do we bother with primary cells and secondary cells? It's all to do with what you put the cells into. I've got two different applications for cells: a clock and a laptop. The difference between the two devices is how much current they draw from the perspective of which type of cell I want to put into them. So this one draws a small current. A clock does not require much current, it requires a small current. On the other hand, a laptop draws a large current. Now, I could put whichever type of cell I like into the clock and it will work. I could put a primary cell in there, or I could put a secondary cell in there, and the clock will work and it will basically do the same job. Okay? The primary cell will be slightly better, but essentially they'll do the same job. A laptop requires a large current, but I can use a primary cell or a secondary cell to provide that large current, and the laptop will work. Okay? Now this is going to last for a few months. This, a few hours, depending on how good your laptop is, how efficient it is. So this one this will last for a long time. Sorry, this will last a long time. This will not last a long time. And the reason for that is the cells, they have a certain amount of energy. This is only requiring a small amount of energy to work, so it will last for a long time. This requires a large amount of energy. The laptop requires a large amount of energy, so the cell won't last as long. Okay, so with that in mind, why would we use a primary cell? Right, hang on, I'm going to rephrase that. Usually, not always, but usually we would use a primary cell in a clock. So why would we use a primary cell? We have to explain why. Well, the clock requires a small current, okay? And primary cells are good at providing a small current over a long period of time. They have good characteristics for that. It's not all they can do. They can provide a large current, I already said that, but they are good at providing a small current over a long period of time. They're also cheaper. Generally speaking, they are cheaper than secondary cells. So that's an advantage. Okay, so that's why we would use a primary cell. They're slightly better than a secondary cell. But let's make this even clearer. Why not use a secondary cell? Why would we not use a secondary cell? Well, related to this point, secondary cells have a slightly higher self-discharge rate. They have a slightly higher self-discharge rate, so they won't last quite as long, but it's not majorly significant. They're more expensive, which is the opposite of that one. What did you say? Expensive. More expensive. And then the other point, the whole point of using a secondary cell would be so that once it's discharged, you can recharge it. Now, charging takes a few hours, so during the charging time for the secondary cell, you can't use your clock. But your clock you probably want to use during that time, so you can't use it, and therefore you might. It's a lot quicker to just replace the primary cell once it's drained. So replacing the primary cell is faster than charging the secondary cells. You can use the clock the whole time. That's an explanation of why we use primary cells in a clock and not secondary cells usually. Okay, you could if you wanted to, but this is an disadvantage situation. Right. The laptop then. As we said, laptop requires a large current, and it's only going to last a few hours for that reason, because the cells, they have a limited amount of energy, and the laptop is going to run it down pretty quick. Why? Now, in this case, we would want to use a secondary cell. So why would we want to use a secondary cell? The reason is we can recharge it. we can recharge the secondary cell once it's run down, rather than replace the primary cell. So to recharge is cheaper than replacing a primary cell. Okay, that's why. And then why not use a primary cell? It's like saying the same thing, but from the opposite perspective. How often would you need to replace the cell in your laptop if you used a primary cell? Because you can't recharge it once it's run down. You need to replace it every few hours, so maybe twice a day. Now imagine you had to replace the cell in your laptop twice a day, or maybe once a day. I'm sure you can appreciate that that would be very expensive. Over the long term, that would be much more expensive than using a secondary cell and recharging it. So you could use a primary cell if you wanted to, but it's going to be very expensive. And you get through a lot of primary cells in a week. So those are the reasons why we would use a secondary cell in a laptop and not a primary cell.